Welcome to this tutorial on naming the functional group known as ethers. Now, ethers are close in structure to that of alcohols. In fact, ethers have the general form of an oxygen with two carbon-containing groups bonded on the other side of it. You can think of ethers as being the dialkyl substituted version of water. So because there is the loss of a OH group, like on an alcohol, the use of a carbon group instead actually sets ethers at a lower priority, much lower priority, compared to that of alcohols. So ethers also have the general name of alkoxy groups. So we'll learn about how to name out these when we have ether-containing groups on seemingly ordinary alkane chains. How do we go about naming these? The parent versus the substituent. Okay, for our first ether naming compound, we'll try something rather simplistic. So first off, you'll notice that we have an alkane chain, but we also have an oxygen with another alkyl containing group on the other side. So when we're looking at the general form of a ether, we want to find out which one of these two R groups, which are attached on either side of my oxygen, are going to have the longest continuous carbon chain. So on this side I have one carbon for methane. On this side I have a 1, 2, 3 carbon for propane. So a methane versus a propane. The propane group is longer, so this will be my parent chain. And now you can think of the other portion of what's coming off here, the OR group. This alkoxy group is the substituent coming off of my longest continuous carbon chain. So the parent name on an ether compound is the same as an alkane. It ends in ane, 3 carbons. So the parent name for this compound is going to be propane. Now, in numbering this propane chain, we want to number to give the alkoxy group the lowest possible carbon number. So we're going to give it carbon 1 on this arrangement. Now the group coming off of this parent chain you can think of as being oxygen going out to a methyl group. Now if it wasn't for the oxygen being in between the parent chain and the methyl group, without it there, we would just call this substituent coming off of the parent chain as methyl. What's different now is because we've inserted that oxygen between the parent chain and the other alkyl group in this alkoxy, this will change over my substituent's name from methyl to methoxy. So this is the name of the substituent. Since it is on carbon number 1 of our parent chain, we do not need to include the number 1. That would be implied. So the full name of this compound is methoxypropane. Now this is the official IUPAC naming designation. When it comes to the common naming for ethers, it is similar to that of alcohols. With alcohols, we name the alkyl group that was attached to the alcohol OH or hydroxy group. On ethers, what you're doing is you've actually got 2 R groups on either side of my oxygen for my ether. So we're going to name both alkyl groups on either side of that ether oxygen. This is methyl coming off of this oxygen, and this is propyl coming off the other oxygen. So when I give this a name, I list out the alkyl groups in alphabetical order: methyl, propyl, and then we end it with ether. So again, this is very similar to our oxygen naming, where we had the name of the alkyl group attached to the OH, followed by alcohol. And the common naming for ethers, we name the 2 alkyl groups on either side of the oxygen, followed by ether at the very end. So common naming here can convey the name of, or the structure of, the ether much more quickly. One thing to know when it comes to ethers is there is one special name to one particular ether. That is an aromatic ether with a benzene ring on one side and a methyl group on the other. This goes by the name anisole. So if you ever run across a methoxy group coming off of a benzene ring that has a special parent name to it, so this falls under the special structure names that were covered earlier, such as toluene, used rather than methylbenzene, or phenol, used rather than hydroxybenzene. So just one thing to note. Okay, in naming this compound, we first want to take a look at and see what is the highest priority group. I have 2 functional groups present. I have an ether group located here, carbon-containing groups on either side of this oxygen, and also a hydroxyl or alcohol group located over here. Alcohol is the higher priority group, so we are going to name this as an alcohol compound. So the priority first will be to get the longest continuous parent chain that contains this highest priority group. Now I can number 1, 2, 3, 4, 5 to get the number 3 for the hydroxyl group. Or I can also number it 1, 2, 3, 4, 5. Either direction gives me number 3 for the hydroxyl group. However, because it doesn't matter with regards to the alcohol group which direction we go, we still get the number 3. The next thing to take a look at is what other substituents do I have I need to make sure to give them the lowest possible carbon number. So the preferred numbering would actually be to go from bottom to top, in which I've got carbon 1, carbon 2 as the lowest possible carbon location for my ether group out over here. So here's my parent chain. So with my parent chain, I would need to designate the position of that alcohol group. 3, 5 carbon long parent chain turns pentane into pentanol. So this is a 3-pentanol compound. Now the substituent that we have hanging off here is an ether or alkoxy group. That alkoxy group, if I eliminate the oxygen that's involved between the parent and this alkyl group, an isopropyl, we would just call it an isopropyl group. But because of that oxygen being inserted between the isopropyl group and the parent chain, we're going to switch from isopropyl to isopropoxy. With the oxy at the end designating that this is an isopropyl group that is part of an alkoxy or ether containing substituent group off of that parent chain. So because it's coming off of carbon number 2, we need to designate that. That substituent will go in front of our parent chain name, 2-isopropoxy-3-pentanol. So the full name for this compound is 2-isopropoxy-3-pentanol. Hopefully these few examples so far on ether naming have been helpful. I will include more in a separate video.